All right, let's get this started. Let's get going. All your tests have been graded. I'm sure you've seen the grade up on Aspen. One comment was a lot of you getting a lot better at the quadratic formula factoring deal, so you're getting a lot better, which was good to see. I still have 2 more people to take it, so once they take it, I'll hand it back. Or if you want to come in on your own and see it, that's fine too. All right, but I thought overall it was a very decent job by all of us. All right, moving on to this week now. Everyone got an assignment sheet. Can you have that assignment sheet out? I got some important details on that assignment sheet. Can you flip it over? Starting today, usually just one Regents review problem every night, in addition to the problems I assign on the front. These problems are not to be done on the assignment sheet. All right, you are to have a notebook, whether it's the one you currently use or the one you're going to get, all right, and have a section dedicated to Regents review problems. So by the end of June, all the Regents review problems are in the same area in your notebook. All right, I would appreciate it if you write out the question and then do the work underneath it. I don't think it's a lot to write out what I have this week, at least. There's not much there to it. All right. Tomorrow you'll come in, I'll pick a person and they'll tell us how they did it. Or they'll just do it from scratch if they haven't done it. I cannot give you any credit if you don't do it in your notebooks. Okay, I just need a section in your notebook filled in. Why are we starting to review for the Regents now? Because I want you to be prepared. All right, by the time June hits and we're actually dedicating full-time class review, you'll have done over 100 Regents review problems already. Okay. So everybody good on that? Please don't do them on the assignment sheet. I don't rip them out of notebooks. I don't want separate sheets of paper. I want it in notebooks. Okay. Before you flip back over, tonight's homework, for some reason, at the end of tonight's problem, Monday night's problem, at the end of tonight, somehow a random segment GR got pasted in there. Can you just cross that out? Because that has nothing to do with the problem. All right, so Monday night's problem tonight, cross off random segment GR. I have no idea how that got in there. Well, I do have an idea, but I won't go into detail on my Microsoft Word issues. All right, flip it over to the front now. You will see, and it's not a typo, you will see no tests or quizzes this week. The next one we have is going to be a week from today. All right, so I'll just give you a heads up, week from today. That'll be the next quiz. All right, and then we do have Valentine's Day coming up next week, so anybody that needs a little help, there's a little help down at the bottom there for you. Okay, just figure I help people out more than just math. Questions, comments, any concerns? All right, let's start this new unit. Calculators, almost on a daily basis, please, for this unit. The plan is to get through homework and you guys leave with nothing tonight. That's the plan anyway. Okay, a couple things about this unit before we start the first section. No proofs. Probably won't see a proof until unit 10. All right, no proofs this unit. There is some, I wouldn't say heavy algebra, but you got to do some algebra to solve the problems. Also, on your calculator, you're finally going to be using that SIN, COS, and TAN buttons that stretch across horizontally on your calculator. All right, you'll finally be using those halfway through this unit. All right. Everyone ready to roll here with the first part? All right, we're still going to be solving proportions. Still going to be solving proportions. Just a quick review from last unit. Do you remember what the numbers we put here and here were called? Those were extremes, yep. And the other two values that we cross-multiplied were called the means. Perfect. All right, we're going to go over a special type of proportion today, when the means are the same and the extremes are different. Okay? The means are the exact same numbers and the extremes are two different numbers. That's called a mean proportional. All right? Let me just show you a quick example. You don't need to write it down. 8 over 4 equals 4 over 2. Does everyone agree that those two are equal, right? That's a good proportion. What do you notice about the means? the same and the extremes different. This is called a mean proportional when the means are the same. All right? So what I'm looking for in this first example is, what are those means when the extremes are 4 and 16? All right? What are the means when the extremes are 4 and 16? I'm not asking you to think about it or guess. We're set up a proportion to solve this. If it's a mean proportional, what do we know about the means? They're both the same value, which we're trying to find, so I'm going to call them x and x, because they're both the same. And in this case, what are my extremes? 4 and 16. Can we solve that? Let's do it. Let's go. Let's solve it. This stuff isn't for free. X squared equals 64. X equals close. Close. Nick? Plus or minus, because when you take the square root, and also take, hey, oh! Go ahead, take -8 and multiply it by -8. What do you have? Positive 64, which is what you get here too. So yeah, plus or minus 8. Plus or minus 8. Are we really going to be dealing with the negative value often? No. What we're going to be dealing with is what's called a geometric mean. That's the positive value of these. All right, the geometric mean. So I want the positive value. So find the geometric mean of 15 and 20. So you know the means are the same. Extremes are different. And yes, this is not going anywhere, unfortunately. Simplest radical form. Means are the same. Extremes are different. X squared equals, what do you guys, 15 times 20 there? 300? Okay. Dig deep, dig deep. I'm going to ask you to break it down. Biggest perfect square that goes in, not the first one, biggest one. That goes in the 300. No sloppy decimals here. Somebody ready to break it down here for me? Let's see here what you have. Number 6. Okay, how'd you get there? Just so we know, Nick.
Broke down the radical 300 to radical 100 and radical 3.
Good. 100 was the perfect square we needed. If you found 25, there was something bigger. And that was going to be 10 radical 3, yes. Okay. Why am I showing you this? Because we're going to set up our own mean proportions today. All right. And we have not left similar triangles. Okay. Not have left similar triangles. So what I need you to do here before we start talking is get yourself a right triangle with this bad boy, which we'll talk about in a second. I just need that diagram down before I talk about anything else. These are the type of diagrams where we're going to live the next 2 days. What type of triangle is the big one? It's a right triangle. ABC, it's a right triangle. I drew in segment AD, and I need you also, I forgot, my apologies, make that perpendicular to CB. Anybody want to give it a vocabulary term? to the name of segment AD. Starts at a vertice perpendicular to the opposite side. Nick, we call that A. That's called an altitude. Everyone agrees. So here's the type of diagram we are working with. We are working in a right triangle with an altitude drawn to the what of the right triangle? What do we call this side here? Hypotenuse. That's where we are. Right triangle with an altitude drawn to the hypotenuse. Now, before I get on to any of this stuff going down here in the text box, how many triangles did I form by drawing in that altitude? 3. You guys, the enriched class here, are going to tell me why all 3 of those triangles are similar. All right, you're going to tell me why all 3 triangles are similar. What were the 3 ways again? Angle, angle, sides, angle, side, and side, side, side. Did I label any of the sides with measurements? So how are you going to prove to me that all 3 are going to be similar? Angle, angle. All right, do it. Ready? I'm going to start. Don't highlight anything. Just right up here. Let's start with this small triangle and the large one. Why would they be similar by angle, angle? ADB and the large one ABC. Why would they be similar? Will? They share angle B. Everyone good? And they have right angles. They're similar. Everyone's good. All right. Why is triangle CAD similar to the big one? Amy? Share angle C and they both have right angles. So does everyone see why these 2 smaller ones are similar to the big one? Final question. Then why are the 2 smaller ones similar to each other? Hugh? Because look, you knew this one was similar to the big one, and so is this one. So the 2 little ones are similar to the large one, so shouldn't they be similar to each other? Okay, now that we know, great job everybody. Now that we know all 3 triangles are similar, what do you know about their corresponding sides? They're in the same ratio. I'm going to help you match up those sides today. Because, all right, let me just throw this out here. If I said, hey guys, take triangle ADB and match it up with triangle CAB, can you please tell me what sides would match up? Do you think you could do it? If I took triangle DAB and CAB and said, guys, can you help me match up the corresponding sides? We'd be here a while. And it's tough. Do you agree that it's tough? So what I've created are 2 devices that will help you match up the corresponding sides so you don't have to do this in your head anymore. Okay? 2 devices that'll help you match up the sides. Ready for the first one? The first one is called Hills. HLLS. Where's the I? It's not there. Get over it. Okay? Hills. HLLS. Let's go over what each letter represents. And it's already right there anyway. The H in Hills, hypotenuse. Hypotenuse of the original right triangle. So for us, what segment would represent the hypotenuse of the original right triangle? 19. CB. So there, now we can start labeling the diagram here. There's the hypotenuse. So that would be CB over L in Hills stands for, as you can see, a leg of the original right triangle. Now there's 2 legs. We're just going to choose one here, but in any problem, you're going to know right away which one to choose. So let's start off here. Choose a leg, please. Choose a leg. 15, choose a leg. AB. So leg, or Emily could have also chose AC, but she chose AB, fine. Let's keep going. L for leg, the same leg, the same leg. And here's where you got to focus. S is for segment. The altitude broke the hypotenuse into two segments. Which one do I pick? You pick the one next to, adjacent to the leg that you picked. If we picked leg AB, which segment is next to, adjacent to leg AB? There it is. So those are some of the sides that match up. And whoa, hey, look at the proportion we just set up. Notice anything about your means? They're the same. And notice anything about your extremes? You've set up a mean proportion here. All right? That's why I showed you the stuff at the beginning there. All right? That will always happen, that the means will be the same and the extremes are different. There's one device. Well, what if that doesn't work for me? What if I don't have enough information to fill this out? We have another device called SAS. This is why all year long I would not allow you to say side angle side is SAS, because there actually is one. All right? There actually is a SAS here. All right, let's set up SAS now. What do you think the S represents in SAS? Segment. All right, give me a segment, everybody. Give me a segment. C, D, you got it. Over. A. Oh, thanks, Mike. There's one piece I haven't labeled yet, and it starts with A, which is the altitude. Yep. So for us, that would be AD. What do you think the other A represents? The second altitude? There's only one in that diagram. And remember, the means have to be the same, right? And then finally, what do you think the other S means? Same segment or different? Because they're the extremes, right? They have to be different. So in this case, if I pick CD here, I got to go DB. So all I'm showing you guys are two little devices that you can use to match up the corresponding sides instead of trying to visually do it on your own, which I don't blame you. I hate doing as well. Okay? Everyone good here? I got Hills and I got SAS. Now the question is, which one do I use given a problem? Let's find out. I only got 3, and then you're on to your homework. All right, let's take a look at A. Everyone, hold on before we go nuts. Do you see the diagram that I need to do Hills and SAS? I see I have a right triangle, and what's this right here? Altitude to the hypotenuse. I can't do Hills and SAS unless I have this diagram. Is everyone clear on that? You can't do it on any random right triangle or any triangle. It's got to be a right triangle with an altitude to the hypotenuse. All right, I'm not going to say anything. I don't want you to say anything either. I want you to figure out, based on the measurements I gave you, why 3 and 9, should this be a Hills or should this be a SAS? Don't yell anything out. I'll give you about 30 seconds, and then I'll show you a little quick trick to determine which one I should use. Do you have enough information for Hills, or do you have enough information for SAS? Because you just can't pick any one you want. You got to pick the one you have enough info for. So I want you to determine what you have enough information for, and then we'll talk. About 15 more seconds. Think some of you have it? Which one to use, which one to match up? Okay, I'll make this easy on you from now on. Ask yourself this one and only one question. Is the altitude involved at all? Did I label the altitude at all? No. So I can't use SAS. If the altitude's not there, I can't use SAS. So I'm automatically going with Hills on this one. Hopefully you determine that as well. This will match up all the corresponding sides for me. Okay, here we go. H for hypotenuse. What's the hypotenuse length? 14. Hypotenuse length. No 14 today? No? Emma, where were you on that one? You're slacking. 19. 12. How'd you get it, Kate? Remember, the hypotenuse is the hypotenuse of the original right triangle, which is 3 plus 9, 12. Over. Leg. I only really care about one of the legs here. 4. Which leg do I care about? Remember, leg of the original right triangle. 9's not a leg. That's a segment, remember. All right? You want a leg of this original right triangle, which would be y. Yep. And what do we know about the legs and hills? Same. They're the means. The means are always the same. Ooh, now this is the tough question. Which segment do you use? 3 or 9? And why? 12. Is that you, Emma? All right. Why? It's 3 because it's the one adjacent to the leg I'm using in the proportion. Perfect. And then we end up with y squared equals 36. Y equals, now for that first problem I use plus or minus. Why do I not want to use plus or minus here? It's a diagram. Can't have a negative side length. Good. So I'm left with 6. Nice job. 2 more, and then you're on your own. All right, let's start us off. 14. Is the altitude labeled? Not here. 8. Is the altitude labeled?
Yes.
Yes, so what do I want to use? SAS, absolutely. The altitude is labeled SAS. All right, help me fill it in now. What's one segment? 13, no. How about 13? No. How about 12? I'm ready. Sorry. Segment. Oh, okay, 12. Good. How about 3? Next, altitude. Let's see if I can get them. Other altitude. Oh, it's the same one. There's only one. Nice job, Sean. Way to go. You didn't get sucked in. Kid's unbelievable. 19. What's the other segment? 4. Remember, it's 2 different segments in SAS. Extremes are different. And then, yes, simplest radical form, kiddos. So break down the square root of 48 for me. Square root of 48 broken down. Number 1. No. 20. Yes, 16 and 3, everybody. 16 and 3, which breaks down into 4 radical 3. Nice job. Let's finish this off. What do you want to use for the final one here? 7. Nice job. Altitude's labeled. All right. Segment. 9. Segment.
2.
2. Altitude. 6. 3. Other altitude. 3. And what should I put in for that last segment? 16? Guys are on fire. It's like a well-oiled machine in here. 2x equals 9. X equals 4.5. Yes. No breaking down of radicals needed. Guys, get this done and get out of here without any homework. Okay?
Numbers.
Yeah, I can. I'll help you out there. I can tell you the last one, number 6, 144 and 25. Everything else should be fine, right?
What's the second one?
40 and 50, and X on the altitude. And then 3 should be, I believe, 4 and 21. Yep, you're good.